So the platform that I'm going to be talking about today is called Crop, and essentially it seeks to alleviate the problem of inefficient irrigation. So what are some of the common problems that are usually associated with inefficient irrigation? The first one would be that inadequate watering of crops usually leads to significant crop loss because of unnecessary water stress. The second is that inefficient irrigation leads to a lot of wastage of resources, whether it be water or nutrients or other things. The third major problem is the potential leaching of nitrates and pesticides that could adversely impact water quality. So what is the solution to the problems that I mentioned? The solution that we've come up with is a mobile application that is essentially an automatic irrigation scheduling application. The user inputs, the data that they have, soil type, texture, and other things, and we calculate the optimal amount of water that they should be irrigating. This is based on the known and tested checkbook model, and essentially we're using a combination of past irrigation, precipitation, geolocation, and other data to calculate the soil water deficit. So these are some of the couple of screenshots that we have. We're going to have a more comprehensive demo at the end of the presentation. What about the business model? So an obvious business model for something like this would be the use of premium features. So for example, if a user wants to have 5 fields, it's totally free. 5 or below, it's totally free. But if they want to have more than 5 fields, they have to subscribe, or they have to pay a certain amount. The second thing would be if they want to get access to comprehensive data analysis features, they also have to subscribe, essentially. What about the future? So what are our next steps if we're going to build this out? The first step would be tuning and refining the algorithm. The second step would be sensory and hardware assistance for local reading. So for example, we could pair the app with rain gauges, water meters, stuff like that, and that would give us more control. The third step would be data collection, aggregation, and analysis at a much greater scale. So yeah, this is the team. Not much to see here. These are some of the references and the APIs that we used. And finally, thank you very much for listening. And now you're going to see a short demo of the product that we built.